All right, so today we are going to talk about three-dimensional figures. This is for 1.7. So we have quite a few vocabulary words on this one, but I think you'll already know quite a few of them. So we'll start. The first word is polyhedron. So a polyhedron is just it's a solid figure with many plane faces, so faces that are planes, and then typically they have more than 6 sides, but that's not as important as it's just a solid figure with plane faces. A face is just like a side of a three-dimensional figure. So if you think of like a cube, we'll see how my drawing skills are today. So if we have a cube, that is not half bad. I'll tell you what. Okay, it's getting worse. You know what? That's not bad. I can live with that. So a plane or a face would be like this side right here would be a face. So that would be a face. An edge would be like the individual little red sides here. So that would be an edge. A vertex is going to be your corners still, just like before. A prism. So what a prism is it's a polyhedron with two parallel congruent faces. So it's got the same thing on top and on bottom. If I flip to the next slide real quick, we can see like this is a pentagonal prism. So it's got a pentagon on top, pentagon on bottom, and then it's got those rectangular faces all the way around. So it's a prism. Whoops, that's not what I wanted to do. A base. So a base is like one of those two congruent, the two congruent faces on a prism. So like the square on bottom and the square on top here would be your bases. A pyramid is a polyhedron that has a polygonal base, so it could have any number of sides. So it could be a triangle, square, rectangle, pentagon, hexagon, heptagon. You could have all those pyramids. And it has 3 or more triangular faces that meet at a common vertex. So unlike the prism, it only has the one base. So like, we'll give this a go. So if I had, that is my base there, and I had a point up here, that would be a pyramid, which is a really, really okay drawing. A cylinder has 2 circular bases, and it's connected by a curved surface on the sides. A cone is like a pyramid, except for it has a circular base, one vertex, and then it's connected by kind of a curved surface as well, but it has a single vertex. A regular polyhedron is a find your words, Mr. Wright. One of those days. So a regular polyhedron would be like, it's a polyhedron that all the faces are congruent. So they're all made up of the same shape that's the same size. So our regular polyhedrons, these are them listed on this slide. So we have a tetrahedron, which is 4 equilateral triangle faces. A hexahedron, or a cube, has 6 square faces. And if you notice that all these are equilateral or regular shapes, that is because they have to all be regular shapes in order to be a polyhedron. So let's go back to definition page. So that's regular polyhedrons. Those were also platonic solids. Yeah, I don't think you'll really need that one. But surface area is the area on the surface. That was a great definition there. So it's just like if you were to lay out a shape, so like if I wanted to make a net of a cube, it would look like this, or it would kind of look like this since I'm a terrible drawer. Then that would be the two sides. So the surface area would be the area of each one of these sides. So area of that, 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 and area of that, all added up. So it's the area of every single face added together. Then the volume would be like, think of this cylinder. Let's just say it was a glass, and we were to fill it up with water all the way to the top, so it's right over at the top. All that water would be our volume. So it's a cubic measurement. It's in three-dimensional space, whereas the surface area is two-dimensional. It's just the area on the outside. It would be like if you were wrapping a present, the wrapping paper would be the surface area, and then the present inside would be the volume, what that shape holds. So if you want to take a minute and write down these definitions, feel free. Pause the video. I'm going to move on. So determine whether the solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. So right away, this is a polyhedron. It's composed of faces that are planes. All of them are flat shapes, so there's no curved sides. So it's a polyhedron. I know that this is a prism because all this, other than the two bases, the two hexagonal bases, which are right here, that's not the one I wanted. I wanted this one. Ha. So we have our two hexagonal bases here. Other than those, everything on here is a rectangle. So when everything else is a rectangle, we know we have a prism. So I'm going to call this a hexagonal prism. Now we have to name the bases, faces, edges, and vertices. So my vertices are going to be all these little black dots. So K, M, or K, P, O, N, M, L, I, H, G, F, E, and J. Then all my edges are going to be these blue lines. So EJ, EF, FG, GH, IH, JI, NH, MG, LF, KE, PJ, OP, ON, OM, LM, KL, PK. We're not going to do a lot of these where we have to label all of them because this is a ton of writing. So as long as you can identify them, that's going to be good. You might have to do one or two on your homework like this, but just know I'm not going to ask you to label every single thing on a test. That seems a bit ridiculous. And then my faces would be polygon PKLMNO, or I'm sorry, that would be one of my bases, would be polygon PKLMNO, and JEFGHI would be my other one. And then all my faces are going to be like LMGF, KLFE, EKPJ, POIJ, OIHN, NMGH, and MLFG. Whew. A lot of faces, a lot of edges, a lot of vertices. Only 2 bases, but a lot of work. So, determine if this is a polyhedron. So, right away, I see it's a cone. I know that's not a polyhedron because a polyhedron has to have all plane faces, and this like circular going to one vertice is not a plane. It's, by definition, it's not a plane. So it is not a polyhedron. I'm just going to name it cone because we know it's a cone. The base would be circle T. And then my one vertice, or my vertex, would be point. Oh, let's spell point right. Point W. This one I like a lot more than the first one. There's a lot less writing on it. But important thing to note is that cylinders, cones, and spheres are not polyhedrons because they are not composed of plane faces. So identify the solid. So triangular pyramid, it looks like a triangular pyramid. Pentagonal prism, it's not a prism. Rectangular prism, it's not a prism. Square pyramid, I don't see a square on there. I just see all of these are triangles. So I'm going to say it's a triangular pyramid. Ooh, this one looks like a cone. Oh, but wait, there's no points, so it can't be a cone. Oh my goodness. There's no points, so it can't be a pyramid or a polyhedron either. It must be a cylinder. Oh. Identifying shapes is fun. So this one, I see that it has 2 triangular bases. So I can color those red. We can see that there's these 2 triangular bases. So anytime I see 2 bases that are a different shape connected by rectangles, I know it's going to be a prism. And I see the first option is triangular prism, so I know that that's it. It's not a pyramid, so it can't be a triangular pyramid or a rectangular pyramid, and it's definitely not a cone. I mean, if you need help identifying shapes, let me know. I'm more than happy to help, but I feel like we just don't need to go through more of these. So this slide is a lot of formulas, and you need to pause the video and put these in your notes. You're gonna need these on quizzes and tests, and it would be ridiculous to ask you to memorize all of these. So please put them in your notes so you have them. It will help you, I promise. So pause the video, do that, moving on. So find the surface area and volume of the cone. Okay, so we have the formula here. T equals pi r L plus pi r squared. So, important note here, my L is this little side, this 5 centimeters that runs kind of diagonal from the point to the edge of the circle. So we're just gonna plug in our values. So don't do that. It's not what I wanted you to do. So T equals pi, my radius is 3, times L, which is 5, plus pi r squared. Pi radius, which is 3, squared. So 3 times 5 is 15, so I have 15 pi plus 3 times 3 is 9, so 9 pi. So if I add those together, I have 24 pi, which is a perfectly acceptable answer. If you want to multiply this out and get a decimal approximation, that's totally fine as well. So if we do 24 times pi, where's my pi button? There it is. We get 75.398. I'm just going to cut it off there. So 75.398 centimeters squared. Since this is surface area, our unit is always going to be squared, because it's a two-dimensional thing. If it's three-dimensional like volume, we use cubed, so to the third power. So the next thing they want us to do is find the volume of this cone. So to find the volume of a cone, the formula is 1/3 pi r squared times height. So let's plug in some values. 1/3 pi, r is 3 squared, times the height, which is 4. So I like to do my squares first. So I have v equals, I'm just going to keep the 1/3 out front now, 1/3 pi. Then my r squared is going to be 9 times 4. So I have 1/3 pi, 9 times 4 is 36. Now, the next thing I'm going to do is I'm going to move that pi to the end. So it's going to shuffle on back over here. And then I'm going to take 1/3 of 36. 1/3 times 36 is 12. So I'm left with 12 pi. And then we would say centimeters cubed, because this is three-dimensional. We're talking volume. If we were to fill that cone up with water or sand or cotton candy or calculators or anything like that. So we can also multiply this out if we'd like. Where's my pi button on this calculator? It's been a long time since I've used one of these. I know it's on here somewhere. There it is. Second, there. So if we multiply that out, we end up with 37.699. So we'll just say 39 or 37.7 centimeters cubed. All right. So all we're doing, plugging values in to our formulas. Find the surface area and volume of the triangular prism. Okay, so our volume of a triangular prism is, it is going to be the area of one of the bases, so one of these triangular bases, times the height. That was really good coloring there. So my area of a triangle is half the base times the height. So half base times height, no, we don't need the colored pencil feature. We need one of these bad boys. So 1/2 base, which is 8, times height, which is 6, times 12. So 8 times 6 is going to be 48. 48 times 12 times 1/2. So I'm going to say half of 48 is 24. So 24 times 12. So 288. So my only one with a volume of 288 is B. But we're also going to find the surface area real quick. So if you check your formula sheet, which I have to get mine open up in front of me. So the perimeter of one of our bases. Oh, you guys don't know how to find that yet. What? So, nope, not that, plus 64. So we're not going to find the surface area of this, but we're going to learn something in the future called Pythagorean theorem that would allow us to find the surface area of this. They technically didn't give us enough information, but essentially, if Pythagorean theorem is a squared plus b squared equals c squared, and a and b are both the sides of our triangle, and c is the longest side, so it's called the hypotenuse. So if we do a squared plus b squared, we have 6 squared plus 8 squared equals c squared, we would get 36 plus 64 equals c squared. So 100 equals c squared. So our c would be 10. And then we could find 10 times 12 is going to be 120 plus 6 times 12 for this side back here is going to be 72 plus 12 times 8 for the bottom here, which is 96, plus the area of two of my bases, which is 24 each, so plus 48. So if we added all these up, 48 plus 96 plus 72 plus 120, we would get 336 feet squared. But like I said, we haven't learned that stuff yet. So Mike is creating a mailing tube which can be used to mail posters and architectural plans. The diameter of the base is 3 3/4 inches and the height is 2 2/3 feet. Find the amount of cardboard Mike needs to make the tube. So I want you guys to try this on your own. My one hint that I will give you is this measurement is in inches and this measurement is in feet. I would make both of them in inches, and that's going to make life a lot easier. So go ahead and pause the video and try this on your own. And then I'm going to write the answer in 5 seconds. So pause the video, try it on your own. So the volume is about 353.4 inches cubed. We were finding the surface area on this one. Whoops. Surface area equals, quick calculation, 399.1 inches squared. Haha, much better. So you can try this one as well, even though I just wrote the answer up there. But it's the same concept, just remember, check your labels, make them both inches instead of leaving one in feet. That's the trick to this problem. And then it's just plugging it into the formula. So Jenny has some boxes for shipping merchandise. Each box is in the shape of a rectangular prism with a length of 18 inches, a width of 14 inches, and a height of 10 inches. Find the surface area of the box. So the surface area of this would be our perimeter times our height. So I'm going to leave my height out of it for now. My perimeter is going to be twice my length plus twice my width. So times 2 is 36, times 2 equals 28. If I add these together, we get 64. So 64 times my height is 640, and then I have to add the area of both my bases, so length times width, which is 14 times 18, so 14 times 18 times 2, which is 504, so it should be 1144, so D. She wants to find the volume now, which we said length was 18, width was 14, height was 10. So for this, all we have to do is multiply 18 times 14 times 10. So 18 times 14 times 10. So our volume is 2,520 inches cubed. So that is our three-dimensional figures lesson. If you have any questions, please reach out, send me an email, send me a Schoology message. I'm more than happy to go over any of this in more depth if you need it. Have a great rest of your day.